Whether your weapon of choice is Bicep or Terraform, modules are a godsend. For anyone writing infrastructure as code, using modules helps reduce the number of lines they have to write and adhering to the dry principle. Don't repeat yourself. But in this video, I will just as much focus on modules from a platform team perspective, especially Azure platform teams. And I'll also talk about Azure Verified Modules, as they are almost just as much of a godsend as well. And since not only talking about these things are enough, I'll show you how to make use of Azure Verified Modules and how you can use them as a basis for your own modules. Modules that will make the life of everyone so much easier. Let's get to it. Alright, so for any one user writing infrastructure as code, they should use modules for their own sake. We've already established that. Don't repeat yourself, or dry, is an awesome thing to live by, so just do that. But for platform teams, I don't see this a whole lot, but I would make the case that platform teams that expect their users to write infrastructure as code, they should strive to make as many modules available to their users as possible. And here's why. Many platform teams set up policies to guardrail their platform and prohibit usage that falls outside of the standards that they or the company has set. But if you've ever encountered trouble deploying stuff due to policy, at least Azure policy, you also know that it can be a nightmare to troubleshoot. You need to have a fair bit of knowledge of Azure policy and the permissions to read them in order to make really any sense of what you need to do differently in your code in order to actually get to the point of deploying your resources. Those error messages, they aren't really helpful or guiding. At best, they will demotivate the crap out of anyone that sees them. So why not consider the saying, you catch more flies with honey than with vinegar? Why not make it easy to do things right? As a platform team, instead of expecting everyone to write resource blocks that comply with your policies, you can make policies that do so with their default settings. That way, not only does the person writing the code not have to worry about satisfying your policies, they don't even have to spend the time and energy on figuring out just what those policies are. And if your policies change down the line, you can simply update your module. Just remember to version tag your modules so that you don't accidentally break everyone's stuff. But over to Azure Verified Modules. How do they fit into this landscape? Well, they are modules. Azure Verified Modules is an initiative by Microsoft that aims to set the standards for what a good infrastructure as code module looks like. They are free for everyone to use and to contribute to. So a lot of these modules are community driven. If you encounter an issue with one or have suggestions for improvement, you are free to simply raise a GitHub issue, or even better, write some suggestion code yourself and then submit a pull request. One of the ideas with Azure Verified Modules is also that they should have best practices built in, because the default values when you deploy stuff in Azure aren't always the best practices. So Azure Verified Modules incorporate stuff from the well-architected framework, and those are often the default selection. You can also nest the Azure Verified Modules into your own, which I highly recommend you do if you're a platform team. More on the why and the how on that later on in the video. But let's use one of these modules to deploy something in Azure, shall we? So I've done a little bit of preparation here. I have written some example code, which is available on my demo stuff repo over on GitHub, so you can grab it there if you want to. Link is in the description. I have also created a couple of resource groups that we will be deploying stuff to. So I have my Bicep demo resource group, and I have a Terraform demo resource group, because I will do a demo on Bicep, and then we'll do Terraform later on. But if I wanted to use Azure Verified Modules in a Bicep file, Bicep deployment, I would be doing it like this. So I have this main.bicep file here. I declare that a module, public IP address, I point it to the public IP address module from Azure Verified Modules. And the reason I'm using public IP in this case is it's a fairly simple resource and thus makes for a simple example. So point it to the correct module and the version of it, in this case 0.8.0, the name of this module, and then the parameters for this is only the one thing, and that's the name. So this is the name that my resource should show up in resource with my AVM public IP -pip. If I wanted to deploy this Bicep file, I would do, let me just go into the correct folder here, and then I'll do a new IaC resource group deployment. The name should be deployment. Resource group will be Bicep demo, and then the template file will be the main.bicep. So I'll just run this command right now. And you know, while that is deploying, you can always hit that like button, subscribe, and all that. And see you in a bit. Right, now that that is done, let us jump on over to the Azure portal and hit refresh. And you see that my AVM public IP -pip is here, and it's a fairly simple and standard public IP. Now, if I wanted to, I could inspect the code behind the module though. You would find, if you do so, that it's a couple of hundred lines long. And my Bicep file, it wasn't all that big. I only have the 6 lines. So it's a very simplification, and I'm not saying that you would have to write a couple of hundred lines of code in Bicep to deploy a public IP address, but it's just an example of what work is lying behind the Azure Verified module. Now, let us do the terraform part. So I have this main.tf file here, which standard terraform stuff at the top here. I declare a variable that is my subscription ID, set up the provider block, and then I run a module. And you see, same kind of setup. I point it to the public IP address module of Azure Verified Modules. The version here you see is 0.2.0, so hasn't come as far as the Bicep one, obviously. I set up the location, the resource group name, and the name of my AVM public IP -pip. So let's go into the correct folder like that. And then we'll do a terraform apply. And I know that you should, you know, do plan and all this, but it's a simple example. It's not meant to be a terraform demo. So I'll just go and, or not a terraform guide or training video. That's what I was trying to get to. All right, so that's done. Let us jump over to the Azure portal, and in my terraform demo, refresh. And now I have my AVM public IP -pip here as well. So that's how simple and easy it is to use. So that's how easy it is to use Azure Verified Modules in your infrastructure code. But as I mentioned, as a platform team, it's not enough just to say to your users, use Azure Verified Modules. No, you should have them come to your registry of modules, because they should have your company standards as the default selections, because they could be different than the defaults in Azure Verified Modules. So enter nesting. What I suggest you do is to create your own modules, and within them you call upon the Azure Verified module. That way you can have the best practices and well-architected framework stuff as a foundation. But on top of that, you put your own defaults. To give you an example of this, the public IP module that we just used in our previous example, in that the DDoS protection is set to inherit the VNet DDoS protection. But say your company policy is to use the IP type of DDoS protection. Then you would make your module call the Azure Verified module, and in your module, you specify that the DDoS protection should be enabled. Then for the end user, the experience would be exactly the same as in my example here. They wouldn't have to specify DDoS because that is handled by your module. So let me show you how that could look like. And we'll start with Bicep this time as well. I have a folder here with a nesting AVM. And here I have a main.bicep. And you see it's same kind of setup, but here I call a pip.bicep instead. So this is what the end user would do. They call the module, and you should probably store it in a better place than just on a file system. Set up your own registry or stuff like that, but that's a topic for a whole nother video. Anyway, they call my module, and the parameters is the name, in this case, my nested public IP. So that's from the end user's perspective. But the pip.bicep in this case, it grabs in the parameter name. But we also specify, we run the module public IP address, the same exact pointer to the public IP address from Azure Verified Modules, the same version, all that. The only thing difference here is the DDoS protection settings. So in this case, enabled. So this is, my module that I create and then made available to my end users. So if I were to deploy this, let's go back to, let's go back to our Bicep folder, and this time go into nesting AVM. And again, I'll do a new IaC resource group deployment. Again, I'll just call the main.bicep. It's the same file, same file name, I mean. And again, calling main.bicep should only do this. Again, calling the pip module. So if I were to run this, there it is, successful. Then head on over to the Azure portal. Let me grab that here. And then in my Bicep demo, hit refresh. And then first, let's take a look at the public IP that we deployed earlier. So if we go into the properties here, you can see that the DDoS protection type is network inherited protection. Now, I do have my nested public IP pip. Properties on that is protection type IP protection. That's how simple it is to have your company standards in a deployment without having to, bother the developers of the infrastructure as code. But let us go back and do the same with Terraform as well. So I have, it's a bit more complex structure due to the way Terraform handles file a bit differently than Bicep does. But I do have the same kind of setup here in my main.terraform. The variable, subscription ID, provider block, all that is the same. And then the module is also exactly the same as when I used a Azure Verified module. The only thing different is the source here, which is located in our module subfolder. So if I were to look in there, I have a pip.tf, and it grabs the variables needed for the Azure Verified module. And again, this is the only thing different from our previous example. And if I were to deploy this as well, let's go into the correct folder and do a Terraform apply. Once that is done, I can go over to the Azure portal and refresh. And now I have my nested public IP, which also, if I go into properties, have the IP protection type. So now that you know how this works and you've seen how simple it all is, I will leave you with this very important message. If you are an Azure platform team expecting that your users of your platform write Terraform or Bicep, shame on you if you're not supplying them with modules like I showed you here. come at me in the comments. I appreciate you taking time to watch this video, and I'll see you in the next one. Cheers.